Alright, ladies and gentlemen, so this is the recording for a trial run of the enzymatic hydrolysis of chicken feather waste for the production of multipurpose high protein biofertilizer. Sound checks have passed. The previous version was scuffed. So this is the new version. In 3, 2, 1, let's go. So, ladies and gentlemen, good morning. My name is Abraham Chor, and here I will present to you the enzymatic hydrolysis of chicken feather waste for the production of multipurpose high protein biofertilizer. My supervisor is Associate Professor Dr. Mickey, and here are my co-supervisors. Here is my problem statement. Chicken feather waste is a common protein-rich waste product of the poultry industry with no clear use case. Chicken feather waste consists of 8% chicken mass. So per chicken, there's 8% feathers and therefore 8% chicken feather waste. They are high in keratin and recalcitrant, and disposal of chicken feather waste is challenging and unprofitable. So, our objectives in the study are first to produce a high protein biofertilizer from chicken feather waste using the enzymatic hydrolysis production method. Number two, to evaluate the optimization potential for the production process of chicken feather waste high protein biofertilizer. So is number three, to evaluate the plant growth promoting properties of high protein biofertilizer produced from chicken feather waste using in vivo tests. The null hypothesis for our research is that high protein biofertilizer produced possesses plant growth promoting properties. The alternative hypothesis is the opposite. Part 1. Production of high-protein biofertilizer hydrolysis from chicken feather waste. Chicken feather waste will be acquired from a small-scale farm from Syria. Gallus are slaughtered on demand on the farm every 1 to 2 weeks, and chicken feather waste will be taken after the slaughtering process. Feathers will be taken from the rotary defeathering machine. Pre-treatment of chicken feather waste will be carried out by cleaning the chicken feather waste with cold water and drying them overnight at 50 degrees Celsius to remove impurities and contaminants. It will then be shredded to roughly 10 millimeter fineness using a grinder and stored in a freezer until use. So alkaline hydrolysis using sodium hydroxide will be carried out using 25 grams of coarse powder mixing with 1 liter of 0.5% sodium hydroxide, heating to 100 degrees Celsius with stirring for 5 minutes. The mixture will then be allowed to cool down overnight under constant stirring. The pH will be adjusted to pH 7 using sulfuric acid. Here are the parameters that we'll be using. So after cooling to room temperature, pepsin and creatinase or no enzymes will be added to carry out enzyme hydrolysis. No enzyme is our control to make sure that the enzymes actually function. So here we have 0 hours and 8 hours as possible intervals for different combinations of enzymes. Sampling for analysis will be taken at these intervals. Approximately 50 ml will be taken at every interval for testing, and the results will be used to adjust the final product. Scanning electron microscope photos will be taken at 5,000, 10,000, and 15,000 magnification. This shows breakdown in chicken feather waste fibers. These results will be used to adjust the final product. So, in theory, you can see these before processing, the fibers are nice and straight. After processing, the fibers are shattered and should, in theory, release more protein. So, the nanodrop machine will be used to assess the content of amino acids and proteins at these intervals. This shows the amount of protein broken down by sodium hydroxide and enzyme hydrolysis. This will be used to adjust the final product and compare protein content from commercially available fertilizer, just normal fertilizer, not biofertilizer. The weight reduction analysis will be carried out will be at that interval, and these sediment will be centrifuged to separate out solids from 10 ml of liquid and weighed. This shows fiber breakdown in solid form to make sure that the amount of fibers actually, in theory, will reduce over time. The pH analysis will be carried out at these intervals, so the hydrolysis pH will be evaluated using pH meter. This is to ensure that the plants will not die if we give them too alkali or too acidic a mix. So, in vivo analysis will be carried out using live plants. The sample from 120-hour interval will be used as proof of concept, and data from part 2 will be used to select the optimum interval to use for future tests. The controls will be commercially available AB fertilizer and distilled water. Cracking non-circulating method will be used for simplicity, and Wok Choy, salad green, and chili will be used. The statistical analysis will be carried out using one-way ANOVA test and Tukey HSD. And the expected outcomes will be that high protein biofertilizer will be able to produce from chicken waste using the enzymatic hydrolysis production method. The optimization potential and plant growth promotion properties will be realized. Here is our work schedule, and here are the references used. Thank you so much. Are there any questions? So as you can see, we have achieved a time of 4 minutes and 36 seconds, which is in in the allotted time of 5 minutes. Thank you so much.